This video will continue looking at Chapter 11, and we are looking at systems of equations in this chapter, and we're specifically going to look at dependent and inconsistent systems. So far we have looked at systems of equations that have ended up with an x and a y, and so a single solution. These are called consistent and independent systems. However, there is a possibility that you can come up with answers and have systems of equations that don't have any solution or have an infinite number of solutions. So let's go ahead and look at some examples of what they are and work on some problems. So looking at an example of a dependent system where you are going to get an infinite number of answers. And so we'll go ahead and solve this and then discuss a little bit more of what that looks like. I'll give myself some room here. So we're going to solve this using the substitution method, which is, I think, the only method that we have so far. And so in doing that, let's get one of these to have an equation that we can use to substitute in. Let's go ahead and get this y by itself. So to do that, let's subtract 3x from this side and this side. We're going to end up with y equals negative 3x plus 5. So we'll use that for y for right now, and we're going to plug it into this equation right here. So let's go ahead and 2y plus 6x equals 10. Substituting y in, we're going to go 2 and negative 3x plus 5 plus 6x, continuing on with our equation. And let's go ahead and remember that when we do this, we apply both of the 2 to both of those, and so make sure to distribute both of them. So negative 6x plus 10 plus 6x equals 10. And then so these will cancel out, negative 6 and 6, and so we are going to be left with 10 equals 10. And so in looking at that, we say, yep, that is true, but that equation, no matter what, if I do it the other way around also, and if I happen to substitute 2y plus 6x into 10 into here, then we'd still get that they equal each other. And so the reason for that is, and so when you look at this equation, you can see, oh, okay, really what this equation is it's just y, it's everything multiplied by 2. And so this is just multiples of the same equation. And so, of course, you're going to always end up then, if they're multiples of the same equation, being a dependent system, and you're going to have an infinite number of answers that are the same. So let's go ahead now then and look at an inconsistent system. In this system, we're going to have that there's going to be no solution. And let's go ahead and see how that works. Again, let's go ahead then and we'll use this one to get y for our substitution. And so we'll go ahead and add 1 to this side and add 1 to this side. So y equals 2x plus 1. And so we will use that to substitute into y for y into here. So we'll use this equation, 2y minus 4x equals 7. Substituting in y, we'll go 2 times 2x plus 1. Oh, excuse me. Minus 4x, carry our equation down, and we're going to distribute into here, and we will end up with 4x plus 2 minus 4x equals 7. The 4x and the negative 4x cancel out, and this says 2 equals 7, which of course we know is not true. 2 does not equal 7. And so if you did it the other way around and substituted, got this where it would be ugly, but either got your y or your x by themselves and substituted in here, then you would find that they wouldn't equal each other either. And so that is by definition an inconsistent system. There is no solution. And that is the end of this video.